Okay, so in this video, we're going to do a review of types of reactions and recognizing them, then about balancing reactions, about writing equations and then balancing them, and then finally about predicting the products of reactions and all of the above, really. Predicting the products, writing out what the molecular formulas are, and balancing the whole thing. Okay, so let's get started. We'll minimize that. So if we were to state each type of reaction and then balance it, from what you see here, I see a compound NaCl is reacting or is turning into sodium and chlorine gas. So when I look at my reaction types, that would strike me as being a decomposition reaction because an element is turning into the two compounds that make it up. So that's a decomposition reaction. So decomposition. So if we were to look at the second type, we'll label them all first and then balance them. In the second reaction, we have one element plus another element forming a compound. In this reaction, you've got a synthesis or formation reaction. So synthesis, or you can call it formation. In the third reaction, I see an element and a compound, and what's being produced on the other side is a different element and different compound. What happens is the sodium is taking the place of one of the hydrogens. The hydrogens are coming out, and now you have a new compound, sodium and hydroxide together. So that's called a single replacement because there was only one replacement happening. So a single replacement reaction, or sometimes called a single displacement reaction, depending on the book and your teacher. And the fourth one, you have two compounds, one compound reacting with another compound. The hydrogen is going where the sodium was, the sodium is going out and reacting where the hydrogen was. So now you have sodium with sulfide and hydrogen with bromide on the other side. There's the hydrogen with bromide, sodium with sulfide. That's two switches occurring, so we call that one a double replacement or a double displacement reaction. Okay, so we've talked about the types. There are a few other types that we have, but that's four types that are given here. Now let's go back and look at balancing each of these. Okay, so in the first one, you have sodium chloride and Na and Cl2 being produced. So if you do a count on this side, on the left side of the reaction, you have one sodium and one chlorine. On the right-hand side, I have one sodium and two chlorines. So I need to get two chlorines on the other side. You're not allowed to just put a 2 here, because then you're changing the molecular formula of what was involved. That NaCl is there because the sodium is +1 and the chlorine's -1. Do not put a 2 there. The only place you're allowed to put these when you're balancing is in the front. So if you took two entire molecules of sodium chloride, that will give you the two chlorines that you need, but it then messes up your count of sodium. Now I have two sodiums on the left. I need to put a 2 in front here to make two sodiums on the right. And that is a balanced reaction. Two sodium chlorides gives two sodiums and one chlorine. Okay, so second reaction. I see one sodium on the left and I see two sodiums on the right. So I need to rectify that. Okay, I also see two oxygens here on the left and only one on the right. So I'm going to start with the oxygens. If there's two here on the left, I need to put a 2 in to make two oxygens on the right. That, however, has increased my count. I now have 4 sodiums because I have two molecules that each have two sodiums in it. So there's 4 NAs on the right. I need to have 4 NAs on the left. And so it turns out that 4 molecules of Na with 1 oxygen molecule will produce 2 molecules of sodium oxide. Okay, so we'll look at part C, our single replacement reaction. We have sodium and HOH, or it's really water, H2O, but written as HOH, and it's producing NaOH and H2. So when I count, the sodiums look great here. My hydroxides look fine, but I have 1 hydrogen here and 2 hydrogens there. So I need to fix that. So if I put a 2 in front, I now have those 2 H's, but I now have 2 hydroxides. So I need to put a 2 on this molecule to give me the 2 hydroxides. That now messes up sodiums. I have 2 sodium here. I need to have 2 sodiums there. So 2 of everything and 1 hydrogen molecule produced. That's how that one would balance. So our last one, H2S, I see 2 hydrogens on this side and only 1 on the other, so I'll put a 2 in. That means I now have made 2 bromines on the right. I need to have 2 bromines, so I put a 2 there. 2 sodiums. I already have 2 sodiums on that side, so it looks to me like everything balances just fine. If I have 2 sodiums, the rest of the count looks good. So that reaction's balanced. 1, 2, 2, 1. All right, so balancing when the formula is given is kind of easy. Let's look at writing out the formulas and then balancing. So now we've got to do some switch rules and look at our periodic table. So we have copper 2 oxide. So copper 2 oxide decomposes, that's a decomposition reaction, into copper and oxygen. So copper 2 oxide means we would take the copper that is a +2 charge, because it says Roman numeral 2, and my oxygen, which is a -2 charge, and form that into a compound. Well, to form copper 2 oxide, I see a +2 and a -2. They cancel each other out. Copper 2 oxide sits just like that, Cu and O. Now, generally, ionic compounds are solids, so we'll call that a solid. It decomposes into copper. So copper is an element, which is a solid, and oxygen we'll label O2 because oxygen's diatomic molecule, so you have to remember when you see oxygen to call it O2, and it is a gas. So there's my reaction written, but it's not balanced. So now that I've formed all my molecules, the only numbers I can change are in front. So I have 2 oxygen molecules over here. I need to have 2 on the other side, so I put a 2 in front of copper 2 oxide. Now I have 2 of those, so 2 coppers. I need 2 coppers there. So we've written our reaction and balanced it. So it looks fine. Magnesium reacts with oxygen to produce magnesium oxide. So magnesium, that's a solid, reacts with oxygen, which is O2, as a gas. To produce means you put an arrow, and magnesium oxide, that's an ionic compound. So the way you write the ionic compound, you write the symbol with its charge, you write the other symbol for oxide ion with its charge. Magnesium and oxides +2 and -2, they get together with 1 of each. So you write magnesium oxide, and it's a solid. Magnesium oxide, solid. Now we need to balance the equation. We have 2 oxygens on this side. We need a 2 there. That gives me 2 magnesiums as well. So 2 magnesiums, and we got ourselves a balanced equation. Okay, in C, carbon tetrachloride. That's actually a molecular compound. Carbon and 4 chlorines, tetrachloride. So carbon tetrachloride decomposes into carbon and chlorine gas. So chlorine gas is Cl2 because it's diatomic. Carbon is not diatomic, so we just leave carbon the way it is. Carbon's usually a solid. Carbon tetrachloride, well, the generalizations in your textbook tell you to assume molecular compounds are liquids at room temperature. However, it may not be a liquid, but if we just stick with the generalization and write that down, you could look it up later and find out if it's actually a liquid or not. But going with generalizations so that we can fill this out, this is what we were told, so that's what we'll do. So now, carbon tetrachloride, copper, and chlorine gas. We just need to balance now. I see 4 chlorines on the left-hand side, so I need 4 chlorines on the right-hand side. I put a 2 in there because 2 chlorine molecules will give me 4 chloride ions, accessible for my compound, and that guy balances just like that. No pitfalls yet. Okay, so for D, aluminum sulfate, so there's compound 1, and lead hydroxide react to produce aluminum hydroxide and lead 2 sulfate. So there's our compounds that we need to write. So we need to write aluminum sulfate. So aluminum is a +3 charge. Sulfate is SO4, and it's a -2 charge. So to get aluminum sulfate to form as a compound, you would need 2 aluminums and 3 sulfates to give a total of +6 charge and -6 charge to balance out completely. So we would have Al2 SO4 3. We'll assume it's a solid at room temperature because most ionic compounds are solids. Then we have lead 2 hydroxide. Lead 2 means you write the symbol for lead, the charge, it tells you +2, Roman numeral 2. Hydroxide is OH, and it's a charge of -1. So to make that compound add up to 0, you need to put a 2 for the hydroxides. So we'll move this over because I'm writing kind of big here. All right. So now arrow. What's produced is aluminum hydroxide. I guess I should just go change the colors. So aluminum is a +3. Hydroxide is still -1. So we have to balance the charges. 1 aluminum and 3 hydroxides would add up to give 0. So AlOH3 makes a neutral compound. And our last one was lead 2 sulfate. Lead is Pb, it was +2. Sulfate was SO4, and it's a -2 charge, so that adds up just fine. And so all these ionic compounds we'll label as solids. Now, in the real world, if these are going to react at all, it would be in an aqueous medium, but it doesn't say in the question that they're dissolved in water, so we won't just make stuff up to confuse you even more than you may be confused already. Okay, so now we need to insert some numbers into this equation because it is not balanced. I have 2 aluminums on the left. I only have 1 aluminum on the right. I have 2 hydroxides on the left, 3 hydroxides on the right. That's going to be a particular problem. My leads seem to be working out just fine, and the sulfurs are all messed up. Okay, so let's, for want of anything else, let's start with these sulfurs. I see 3 SO4s on one side. I'm going to put in a 3 over here, and that will make 3 SO4s. Now I have 3 leads on the right, so I come back over to the left and put in a 3 there to make 3 leads. This gives me 6 hydroxides. To get 6 hydroxides, I put a 2 in front of my AlOH3 because 2 times 3 makes 6 hydroxides. Now I've got 2 aluminums, and I need to, I've already got 2 aluminums. So 1 aluminum sulfate reacts with 3 lead hydroxides to produce 2 aluminum hydroxides and 3 lead sulfates. That was the trickiest one on there thus far. All right, so now all of a sudden I get the questions when I tell you that potassium chloride decomposes. Well, decomposes into what, some students will ask. Like, how am I supposed to know? What am I, a magician? Well, no, it's potassium chloride, a decomposition reaction. We already saw that means it breaks up into the elements that made it up. So potassium chloride will break up into the elements potassium and chlorine. So we'll write our formula for potassium chloride. Potassium is a +1. The chloride ion is a -1. Those two charges balance just fine. So potassium chloride, KCl, we'll call that a solid. It decomposes into the elements. The elements are potassium and chlorine. When you write Cl by itself, it's diatomic, Cl2, and it's a gas. So KCl breaks up into potassium and chlorine. All that from the word decomposes because it breaks up to the elements that make it up. So now we balance the reaction. We have 2 chlorines on the right. We need to put a 2 in front of the entire molecule to get 2 chlorines on the left. 2 Ks on the left means 2 Ks on the right, and we got ourselves a balanced reaction that we wrote ourselves and then formed. In B, it says silver and arsenic react together. Well, silver is Ag, and that's a solid. Arsenic is As. We're not sure solid, liquid, or gas. It is a non-metal, even though it's a metalloid. It's in between. It's on the staircase. But the hard and fast rule that we've been taught is that if it's a non-metal, call it a liquid until you find out different. So if those two react, what will form? Well, I don't know. But if I see an element and another element reacting together, we look at that as a formation reaction, which means 2 elements will combine to form a compound. So we'll react them together. So we write silver and its charge, so silver +1. The arsenic ion is arsenide, and it's As -3. So silver arsenide is the reaction, or is the compound, excuse me, and you'd need 3 silvers to bond with 1 arsenic ion. So we have Ag3S. Now that we know those numbers, we see that we have 3 silvers on the right-hand side. We need 3 silvers on the left-hand side to make that work out. All right, 2 more. So potassium reacts with strontium acetate. So we have an element reacts with a compound. Whenever we had an element and a compound react, we called it a single replacement reaction. So potassium as a solid reacts with strontium, which is +2, and acetate, which is CH3COO. Some of your textbooks call it C2H3O2. Acetate is a -1 ion, so strontium acetate, you'd need 2 of those to bond. What will you get produced? It doesn't tell me what to produce, but a single replacement reaction means that the metal here, K, potassium, will exchange spots with the strontium, and strontium will go by itself. So you should get strontium alone, and then you link up potassium +1 with our acetate, CH3COO, which is a -1. So now we have our reaction written. We just need to balance it. So I see 2 acetates on one side. I need to put a 2 in front of this compound to make 2 acetates on the right-hand side. 2 potassiums on the right means I put a 2 here to make 2 potassiums on the left, and everything now counts out just fine. Last question. Copper reacts with silver sulfate. Silver is Ag, it's +1. Sulfate is SO4, it's a -2. So silver sulfate is Ag2SO4. Those 2 are going to react. Well, this is a single replacement reaction again because an element reacts with a compound. What happens is the metals will switch spots. Silver will come out and form on its own as a solid, and then you will have copper reacting with sulfate. So Cu and SO4. Well, SO4 is -2, but we're into a little conundrum here because copper has more than one charge. It's multivalent. Copper is sometimes a +2, and other times it's a +1. This question didn't tell me which ion charge copper is. It didn't say copper 1 or copper 2. So the convention we're going to use is, if we're not told in the word, we're going to assume that the most prevalent one, the most common one, is the one that we're dealing with. That happens to be the one written on top on the periodic table. So copper +2 is the one that's written on top. So we will choose that one as our charge for copper. Copper +2. That means that the +2 and the -2 ion charges balance completely, and copper 2 sulfate forms as CuSO4. Okay, so we have copper 2 sulfate, copper solid here, and silver sulfate. Now we need to balance it. It looks like it's almost balanced. We have 1 copper on both sides. We have 1 sulfate on both sides, but it's the silvers that are messed up. There's 2 silvers here. So by inserting a 2 there, we have our 2 silvers, and we've got ourselves our last balanced equation. Hope this helped you out with the review.